So negative 20 is the A11 of matrix A. The A11 of matrix B is negative 10 minus 10. If we solve that, we also get negative 20. Therefore, the A11 of both of these matrices is equal. So check. Check on the A11. Let's check out A12 is 33 in matrix A and 33 in matrix B. It checks out. What about the A21? A21 is 15 in matrix A and 15 in matrix B. That checks out. What about the A22? In matrix A, it's negative 15. In matrix B, it's minus 5 minus 10, which also equals minus 15. So the A22 also checks out. Therefore, matrix A equals matrix B. Okay? We not only have the same number of elements, we also have the same dimensions, and each of the elements within the matrix correspond with the elements in the next matrix. That is the two conditions that you need in order for matrices to be equal. Alright, so take a moment here to pause and do these examples on your own. Alright. Okay, so you should have written these down in your notebook and done these examples. So the first one, what you should have noticed right off the bat is that these matrices do not have the same number of entries and are not the same dimensions, so therefore they cannot be equal. In the second one, they have the same number of entries, they are the same dimensions, so we go through and check each one. We have 5 and 5 correspond in the A11 spot. In the A12 spot, we have 3 and 3, but when we get to the A13 spot, we have 3 here and 2 here. Therefore, these matrices cannot be equal because of condition number 2. This one was not equal because of condition number 1, which said that you need to have the same number of entries and the same number of rows and columns. Condition number 2 says that you have to have equal corresponding elements, and you see in this section right here, they do not have the same or equal number of, or equal corresponding elements. I'm sorry. So if we look at this one, of course, we've done one that didn't meet condition 1 and didn't meet condition 2. This one, of course, has the same number of entries and elements, and it has the same dimensions, and also every element corresponds with another, or the corresponding element of each of the matrices are equal. Therefore, these matrices are equal. Okay, number 5, identify the missing elements of matrices using the rule of equality of matrices. So we're going to use the knowledge that we just gained on the equality of matrices in order to apply it. So in these types of problems, you are going to be given that A and B are equal. So we are going to assume A equals B. We are going to find X and Y. So if A equals B, we know they have the same dimensions. We're going to work on condition number 2. Condition number 2 says that corresponding elements have to equal. So we know that A11 has to equal A11 on this side. Therefore, X equals 1. Alright, so A12 must equal 2, and it does. A21 has to equal 3, and it does. And A22 equals 4, and we have the variable y here, so we know that y equals 4. Pretty simple. Most of it is just attention to detail, making sure you're paying attention to the specific row and specific column. So let's try another one. Alright, given that A and B are equal, find x, y, and z. This one is a little bit different because we have equations. So 4 is equal to x, so we have x equals 4. Okay, let's do a double check just to make sure this is 0, this is 0, this is 6, this should be 6. Okay, Now we get to -2 equals, and on this side we have an equation, y plus 4. So all we're going to do is use algebra in order to solve this. So if we just minus 4 from both sides, we get -6 equals y. So we have our x and we have our y. All that's left is the z, and we know that 3 should equal this. So we have 3 equals z over 3. Remember that the opposite of dividing is multiplying, so we're going to multiply each side by 3, and we'll get 9 equals z. Okay, so that the rule of equality of matrices can be used to solve for the variables within the matrix. Alright, so I'd like you to pause your video here and try this example on your own. We have an x, y, and a z. Okay, you should have gotten that x is equal to 3 because these match up. They're both A1, 1. 1 and 1 are okay, they're equal. Okay, y should have been equal to 0 because those are both the A2, 1 positions. And -2 should have been equal to z. Alright, continuing on. This is where things get a little bit more difficult. This section requires that you have a lot of attention to detail, okay? You have to make sure that you first check that the dimensions of the matrices that you want to add or subtract are the same, okay? The first thing that you need to check is that the dimensions of the matrices are the same. If they are not the same, you cannot add or subtract them. So don't try to go through the trouble of adding and subtracting them if they're not the same. Check the dimensions first, okay? So when you're adding and subtracting matrices, you want to check and make sure that the dimensions are the same. So we look at these, we have a 1, 2 rows and 1, 2, 3 columns, so this is a 2 by 3. Okay, and this is a 1, 2 by 1, 2, 3, so it's a 2 by 3. Okay, so we're all set. We can go ahead and add. If we want to add these matrices, we need to add the corresponding elements, okay? So we need to line up A11 with A11 in the other matrices. We have 1 plus 10, okay? So then we need to add up A12 with A12 in this matrix. So we have 2 plus 8, and so on and so forth for the remaining entries. The important thing to remember is the resulting matrix should be the same dimensions as the matrices you're adding. So it should be a 2 by 3, which this is a 2 by 3, so that's correct. This requires a lot of attention to detail to make sure you are lining up the correct entries. It is very easy to accidentally use 3 and 1, make a mistake in lining up the entries. So make sure you're very diligent. I think that it helps to write this out in the brackets in order to make sure that you are adding the correct entries with their corresponding. Okay, let's try subtracting matrices. Again, we have to remember that the dimensions of the matrices must be the same in order to add or subtract them. Okay, that's the first thing we need to check. So we'll check right now. We have 1, 2 rows for this matrix and 1, 2, 3 columns. This is a 2 by 3. And then we have 1, 2 rows and 1, 2, 3 columns. So that checks out. The dimensions of the matrices are the same. So we can go ahead and subtract. This is very much like adding. Okay? We are going to take the corresponding elements in each matrix and subtract them. So instead of an addition sign, we're going to have a subtraction sign. So 1 minus 10. We're going to take the next entry or element, 2 minus 8. Okay? So, and so on and so forth with the remaining elements. Okay? So I put these in parentheses, the negative signs, so that we can see here when we do 3 minus a minus 7, so subtracting a minus 7, we are actually going to end up with a plus sign here. So 3 minus a minus 7 is actually going to be 3 plus 7, which is how we got 10 for this entry over here. Again, the resulting matrix also should be a 2 by 3 matrix, since that is what we started with. And we'll see here we have 1, 2 rows and 1, 2, 3 columns, a 2 by 3. So that checks out as well. I'd like you to go through, pause the video, and make sure you understand where these numbers are coming from. Again, one of the reasons we went over the A, I, J elements is so that we can make sure we line up the A, I, J elements of each matrix with the corresponding A, I, J elements of the next matrix. Again, this requires a lot of diligence and attention to detail in order to do this correctly. So take a moment to pause and make sure that you understand where each of these elements are coming from and that you got the same resulting matrix. Okay, so let's look at what happens when you don't have the same dimensions for a matrix and you try to add them. We said that it's very important to line up the same elements. So here's the A11 of this matrix, here's the A11 of this matrix, so here we have them here added together. However, when we take the A12 of this matrix, there is no A12 of this matrix since there's only one column. Therefore, we have nothing to add 3 to. So this cannot occur. When they don't have the same dimensions, here we have a 2 by 2, and here we have a 2 by 1 matrix. Therefore, we cannot add these. Okay? Let's try another one. Here we have a 2 by 1 matrix trying to add to a 1 by 2. So it's very important to know that these dimensions are not the same. They are not the same, so we cannot add them. There's no way to flip this to make it a 2 by 1. It will not work, so it needs to stay the same. Therefore, these cannot be added. So make sure that you are not trying to flip these. They are different dimensions, therefore they cannot be added. Save yourself the work. You don't need to add these. They cannot be added. So I'd like you to pause the video now and go through these examples on your own. Make sure that you are diligent about adding the corresponding elements in each matrix. Okay? And pause now. You should have paused your video and done these matrices in your notebook. I will be requesting that you turn them in as proof that you went through this vodcast. So that's the end. Have a great week.